Welcome back, everybody. We are in Newton's second law today, and Newton's second law is actually easier to remember than the first law. First law is that an object at motion tends to stay at motion, an object at rest tends to stay at rest unless acted upon by an external force. Newton's second law is described as a formula. It says that the force is required to accelerate a mass. So whatever that you have as a mass, the smaller the mass, the smaller the acceleration needed to accelerate that, or the smaller the force needed to accelerate that mass. The larger the mass, the larger the force. These are on opposite sides, so this is direct relationship. These are these are inversely related. So at the same force, if I have a bigger mass, it's going the same amount of push on that mass will not accelerate it as much. Okay, so imagine that you're in outer space and I throw a rock, I put a force on it. I can accelerate that rock as long as the force is with the rock. Now, if I release it and there's no more force on it, it's going to continue at a straight line. But if I can keep a force on it, then I can accelerate that. Okay, so if you put your accelerator down on the car, you are putting more and more and more and more force. You're increasing the force, and then the mass of that car is accelerated as a result. So, nice, easy formula. This is a formula most people can actually remember all the way through physics, and you may actually be in the nursing home and still know how F equals ma. You won't know your name or who your kids are, but you'll remember that mass times acceleration equals force. Good for me. All right, so let's look at this first example. A large mining dump truck has a mass of 40,000 kilograms. Now that brings us to the first point here. Mass has to be in kilograms, and I'll show you why in a second. So let's say that I have a kilogram, and if you remember, acceleration is meters per second squared. So kilograms times a meter over seconds squared is the units of force. So force can either be kilograms meters over seconds squared, or we've given it a name. Someone else gave it a name. They named it after Isaac Newton and called this unit the Newton. So the unit of force is named the Newton, and the Newton is equal to 1 kilogram times a meter over second squared. Meter over second squared comes from acceleration. Kilogram comes from mass. So all mass has to be in kilograms for it to cancel with newtons. So you can't have newtons of force and grams or pounds of mass. It wouldn't work at all. All your numbers would be ugly. So in order to cancel everything out, you have to have kilograms, meters, so you can't have centimeters, meters per second. Okay, meters per second squared. So let's fill in what this says. We've got 40,000 kilograms. Okay. And it's asking for the acceleration, so we'll do that. It'll be meters per second squared. And then it produces 20,000 newtons of force. So if I want to rewrite this, this is 20,000 kilograms times meters over second squared equals 40,000 sorry about that, kilograms times A. Then kilograms will cancel with kilograms. Your answers will be in meter per second squared is what you want. So 20,000 divided by 40,000 is 0.5 meters per second squared equals acceleration. Okay, so it's very simple, really easy. You're just going to want to solve for whatever you don't know. You're either solving for F, solving for M, or solving for A. So let's look at these three. I'd like you to do these yourself. I'll set them up for you or help you a little bit and give you some pointers, and then I'd like you to do these completely and then turn them in the box. The truck described above dumps its load and its mass is reduced to 10,000. So we know, assume its engine still produces the same force. So we know it produces 20,000 newtons. Otherwise, it's called 20,000 meter or kilogram meters over seconds squared equals Now we don't have 40,000, we have 10,000 kilograms, and it's asking for the acceleration. So you're going to solve for A. You'll have to get A by itself. You can see that kilograms is going to cancel with kilograms, leaving you meters per second squared when you divide 10,000 into 20. How much force does the engine of the dump truck described above develop? So I assume it's the one with the 10,000, not the 40,000. So it's saying how much force, so we're going to ask for force. So force in newtons equals 10,000 kilograms, and we want it has an acceleration of 3.5 meters per second squared. So the units will be kilograms meters per second squared. That's a newton, so you can express this in newtons. So just multiply and express it in newtons. Number 3, we've got grams. That automatically raises a red flag. If I have newtons, the only way that everything is going to cancel is if I'm in kilograms, meters, and seconds squared. So I have to trade this in for grams to kilograms. 1,500 grams. There's 1,000 grams in 1 kilogram. So I have to divide by 1,000, so I'll move it to the left 3 places. 1, 2, 3. So I have 1.5 kilograms. All right, so I've got a 3 Newton force. I've got a 1.5 kilogram toy, and it's asking for its acceleration. Remember, this is the same as saying 3 kilogram meters over second squared, and then kilograms is going to cancel with kilograms, and your answer will be meters per second squared. All right, good luck.